Godot 4 adds heaps and heaps of improvements to the particle system. You get things like attractors to move your particles around, you get specific new emission shapes, you can instance when specific particles are going to spawn, heaps of new cool stuff, but the really cool new thing I want to focus on is the new physics system. So the new particle physics system hasn't existed before. I made a really long-winded tutorial on how to get physics set up for 2D particles. And the reason it's difficult to do is because there are a lot of hoops you've got to jump through when you're writing code that makes particles. Because you've got lots and lots of things to keep track of, and all of their information needs to update and render in real time and not lag your system out. And moving lots of things around is a difficult task to do. So the way GPU particles tackle that is by being shaders under the hood, stuff that runs specifically on your graphics card. So it's really performant code that has a lot of hoops it jumps through to get as fast as possible. So what it needs to do is every frame it needs to know where to position everything, not keep track of too much information, not have too much information going between places where mistakes can be made because you don't want your particles jumping between points. There's just a lot to tackle and it's not an easy job to do. So these particles run as shaders, but telling them where things in the world are, the actual collision shape of the environment you're in, that's not an easy thing to do in a performant way. You don't want to be tracking a collision shape for every particle you've got, comparing that to all the collision shapes in your world, every frame for every particle. That's an awful lot to keep a track of. So what Godot 4 does is it introduces a few tools for different environments where it really excels, and lets you pick whichever one you want to create these sort of performance-friendly collision shapes that the particles can interact with. So the first one that's worth looking at, and the probably most generally useful, is the HeightField. What a HeightField does is it's a box around a specific point, and it will check the height of every point around it, and you can choose the resolution you want it to look at, so you can tell just how finely grained it will look at every point in this box, and it will calculate a height for that point. Then, whenever particles are trying to interact, they just look up the height they're supposed to interact with at that given point. This system really excels when you're dealing with terrain. A perfect example would be something like rain or snow. That's falling overhead, you want it to bounce off of rocks, or you want it to at least do something when it hits the floor rather than just disappear. Well, what you can do is you can attach a height field to your player, and then it will update in the area around you. That means you're not calculating these collision shapes for a really large area, only the area nearby the player where they're really going to notice whenever water, blood, snow, whatever hits the floor, or even shocks for attacks and VFX particles, that sort of thing. So this is ideal for that case. It also has a few extra properties to control how often it will update, because you might have a generally static environment and not really want to update this information every frame. You can either update it once, or whenever the camera moves. If you're in something like a first-person shooter, as your character moves about or as you look around, the height field will update around your player. So I think this is the easiest to get up and running with as far as getting collisions working off the bat goes. Once you've got the height field in, there are then a few extra toggles we can deal with inside the particles themselves that will then allow them to actually collide. If you go into your particle material, you scroll down to collision and you enable it, you then get a few extra properties you can fiddle with as well. You get friction, that's going to control how much the particle will stick to surfaces, and you also get bounce, that's how much it will bounce off those surfaces. I spent an awful lot of time fiddling with these two properties. You can really spend a lot of time trying to make everything look the way you want it to. By the way, Godot for Beginners, my course for learning Godot 4, discount code in the description, particle physics. Yeah, 30% off. So there are two more key cases worth looking at. If you have a simple setup and you know you have one thing and you know the shape it's going to be, and you want that to have physics and you want it to just be reliable and work, you can manually set individual shapes for the collisions themselves. You can either do cuboid shapes or you can do spheres. So I've got a ball pit over here. We have particles that just spawn, they just collide, and then each of the walls and the floor of this ball pit are cuboid collision shapes. So the GPU particles will bounce off the floor. If they get to the edge where the walls are, they'll bounce off. I've found this to be very reliable for calculating the collisions. The problem is it is slow to set up. I would only recommend it if you've got a very simple environment. You can also use the sphere. I put a sphere collision shape on the player to just just give a sense that particles are colliding when they're around their character. It also means that when you walk around in the ball pit, the player will actually push them out of the way. It's pretty cool. I have noticed that if a particle spawns inside a collision shape, it will usually jump to immediately on top of it. Can look funky sometimes. It's, you know, it's cool. It's cool new stuff. It's really fun to put a blood and guts squirting out of things, and oh, I'm on a list now. Okay. FBI, open up! The last approach is generating a signed distance field, which you'll be familiar with. It's really popular in this iteration of Godot. What you can do is you can define an area and you can bake in information about collision shapes inside that area. I've had the most trouble setting this up, but once you know what you're doing, you can get reliable results. My problem is that with resolution, if the resolution's too low, which it seems to default to, it just looks like the collisions aren't working, which is unfortunate. And if you set the resolution for the signed distance field really high, you end up with absolutely giant files, which isn't desirable, even though you get accurate collisions, which is nice. But the gist of it is you pick an area with something complex you want particles to accurately bounce off of, and you bake it at the resolution you want. You can't have your object be moving. You're going to get a set collision shape that, you know, isn't going to, you're not going to be able to update in real time. Baking it is a very performance intensive process. So, you know, be wary when you're dealing with that. So out of this whole setup, you end up with 3 different particle physics approaches for different problems, height fields for general terrain around you, simple sphere and cuboid shapes for simple shapes that you want to tackle, and SDF as an approach for complicated shapes you want collisions to appear around. The demo Godot for beginners, you'll be able to try out all of these in real time. We'll serve you by the course, you'll get access to source code, and you'll get guides as they're released. Final note about that, navigation server demo is going up today, and do check out that discount code. Okay, thank you very much for watching. Been a pleasure. See ya.